Anak saya makan. Okay, now let's move to number 5. Yeah? Okay, so if you look at number 5, here I want to test the hypothesis, the randomness about this about the 24 consecutive downtime in minutes for a particular machine. Now, please take note. Usually, in the question or in the test or whatever, I don't mention. If I ask you to test for randomness, I do not mention about the median or about the mean. I do not mention that. Yeah, but you have to keep in mind that in order to test the hypothesis whether there's a randomness of the sample, you may base on the mean or you may base on the median. But I prefer based on the median because median is less sensitive to the presence of outliers. So you always use median. Yeah. Okay. So meaning that here, to test this for randomness, the symbol is not given, right? I mean, we do not know the symbol. Yeah. So we have to assign symbol. To assign symbol, I need to first find the median. Okay. So for this, what is the value of the median? First, get the value of median. What value of median that you get?
33.
33, isn't it? So you should get 33. Then you have to tell me, which is X, which is Y. Because if you do not mention, I do not know, which one you want to use as X, which is as Y symbol, So here you have to mention, let's say said X, I assign X if the observation is less than median. If less than median, if less than 33, I assign X. If more, I will assign Y. More, I will assign Y. Then you, assign the number of X and Y accordingly based on this, whether it is less than or greater than. How about if the value is exactly equal to 33? What happened? If the value is equal to 33?
Delete.
Okay, so you delete that observation. Yeah, so you delete that observation. So by doing this, number 5, after deleting those observations which is equal to 33, and after assigning X and Y, what is the R? The values of R? R should be what? The R? What do you get for R?
6.
R should be 6. Okay, good. So reject if R less than the critical value. What is the lower critical value? W 0.025. Yeah. So you should get what?
8.
8 kan? 8. Reject if this 6 greater less or equal to 8 or greater or equal to 0.025. What is greater or equal to the upper critical value equal to what?
16.
So reject or not to reject is not?
Reject.
Reject is not. For this case, reject is not. So any question on the run test? Now, another thing that I want to highlight here is that all you have seen here, all this question is based on the small sample, isn't it? Small sample, yeah, where when I say small, meaning that values which appear in the table, right? If the value of R, if the value of the sample not appear in the table, so you may treat them as large sample. Yeah. For large sample, you have to remember how to test for randomness for large sample. It's all from the small sample. For large sample, how do you test the hypothesis? Just answer me. For large sample. So what is the formula? Z equal to R minus the expected. So you have to remember this expected value of ER divided by the square root of the variance of R. So once you get this, once you simplify this, then you have you look at the formula for ER and look at the formula for variance of R. Then when you simplify this, you look at the standard normal table. Yeah, please take note on that. Use standard normal table. Okay, any question before I move on? This already. Okay, next we move on to tutorial berapa tu? 3 sekarang Perlu 3. Okay. So here, for testing paired replicate data. So look at this. This is a paired replicate data. For paired replicate data where 2 observations are taken on the same object. Same object. Before and after on the same object. So we may use Fisher sign test or Wilcoxon sign rank test. However, I already mentioned to you that Wilcoxon sign rank test is more preferable than the Fisher sign test because this is more efficient than the Fisher. Okay, anyway, just have to remind you that Wilcoxon sign rank test or Fisher is used to test the hypothesis for paired replicate data when the samples are dependent sample. Dependent sample when 2 observations are taken on the same object, or if it is not taken on the same object, meaning that samples which are already dependent, like husband and wife, twins, those are dependent sample. Okay, okay. So number 1, for number 1, what do you get? So for Fisher sign test, the S star here, what do you get? 5, isn't it? 5. For Fisher here, you should get 5. S star equal to 5. And reject H0 if, because we want to, so before, so after minus before, after minus before. If after minus before, if you write H0, MD, median of the difference equal to 0, H1, MD greater than 0. So meaning that after minus before. So you get S equal to 5. And reject H0 if, for reject H0 if S greater or equal to, can you get directly from the table for Fisher exact test for the upper critical value?
Oh.
So here N, you should minus N minus at 0.01, if you look at the value, should be what? This should be 0, right? So this should be 7. All right, so fail to reject H0, fail to reject H0. But if you use Wilcoxon sign rank test, what value of T that you get? T plus?
25.
You should get 25. And then reject if T plus greater than Greater than what?
22.
22. Yeah. So for this, if you use Wilcoxon, what do you get? Is the answer the same or not? I mean the conclusion.
No.
Conclusion not the same, right? Here fail to reject, but here reject actually. Okay. Okay, well, should be number 2. Actually, this should be number 2, but well, whatever, number 3. Okay. All right, for number 3, or actually number 2, what do you get? Because this is very simple, so just quickly run over this. Yeah. Number Fisher, what do you get for Fisher? S equal to
17.
17. Yeah, you should get 17 here. And then for Wilcoxon, what do you get? T plus
182.
182. Is it exactly 182?
183.
182.5. Okay, so both reject H0, right? Both reject H0. Both reject H0. Okay, now move on to number 4. Number 4. Okay, Berlin Wilcoxon. Okay, let me just erase this. Okay, for number 4A. Yeah. For A, what is this plus?
21.
Yeah.
21.
21.5, isn't it? You get 21.5. Then you should get 21.5. And then point estimate. How about the point estimate? Based on Wilcoxon's and rank test statistic, find a point estimate for the median of the difference.
4.5.
Should be 4.5. Yeah, here should be 4.5. 4.5. And please note, please note, just want to highlight this. Here, I mean, when you want to find the point estimate or you find the confidence interval, the difference which is equal to 0 should be included in the analysis. The difference which is equal to 0 should be included in the analysis. So number 3, part 2, 90% confidence interval. The lower interval should be what? The lower interval should be negative
4.5.
4.5. And the upper interval should be
13.
okay, correct. Okay. All right. So that you have to understand that. Next, we move on to number 5. And then each husband and wife was asked how much money. Okay. Based on the sign test, find 90% complete interval for the median amount of what husband spent in excess of what his wife spent. Okay. So here number 5. Okay, so since I basically mentioned that I want to find the confidence interval for the median amount of what husband spent in excess of what his wife spent, so we need to subtract husband minus wife. So here my husband minus wife get the differences. Then get the median. The point estimator median is equal to what? MD? MD? MD head? MD head. What is MD head? MD head equal to 2? 2. Equal to 2. And then interval estimate?
21, negative 21.
Negative 21. Yeah, so here negative 21. Yeah, and the upper should be 33. Okay. Right? Okay, now here I want to highlight here. If I do not mention whether to use Fisher or to use a Wilcoxon and rank test, yeah, I prefer you to use the Wilcoxon sign rank test, Wilcoxon sign rank statistic. Yeah, why? Because it is more efficient. Compared to the Fisher. All right. Okay. Any question here? No question. We move on to the last question. Yeah, the last tutorial for. Okay. Okay. If you look at tutorial 4 number 1, tutorial 4 number 1, for this for this question, I specifically mentioned that you use the Wilcoxon rank sum test. Yeah, meaning that here I want to compare two independent sample. Yeah, I want to compare. Yeah, in order to use, to test hypothesis for two independent sample, I have to use Mann-Whitney test statistic. Yeah? So please do not get confused. Given a problem, you have to really understand whether the samples are dependent or not independent. Yeah? If you wrongly understand that the samples is dependent or independent, then all your answer will be wrong. So it's very important here. Yeah. So for two independent sample to test the difference between two population median, I have to use Mann-Whitney test statistic. Okay. So Mann-Whitney test statistic, there are two techniques how to do that. Yeah. One, the first technique is you compare the number of X to the left of Y, and then the number of Y to the left of X, and then count. Yeah. U1 and U2, number of X to the left of Y, the number of Y to the left of X, U2. Yeah. That is our first technique. The second technique, use Wilcoxon rank sum test. Okay. Fourth technique will give you the same value of Mann-Whitney. If it is not mentioned, if I do not mention in the question whether to use Wilcoxon rank sum test or directly use the comparison number of Y number of Y which is less to the left of X, number of X to the left of Y. If I do not mention that, is to your choice, whether you want to use either one. If I specifically, like in this example, I specifically mention use Wilcoxon rank sum test, then you use Wilcoxon rank sum test. Yeah, understand that? Okay.
Yes.
So for this, at the 10% significant level, can you conclude that median writing speed between the two sexes are different? Yeah. So here, since I do not know, I do not know in which direction. I not specifically mention whether to test whether the male is, their speed of writing is better than the female or whatever. Yeah. Or the female better than the male. I'm not sure. If I'm not sure, always I write they are not equal to. So median 1 not equal to median 2. Here you have to mention 1 you use for what? For male, female I use 2. So you have whatever you write, if you have to clarify to me. Yeah. So if you make use of Wilcoxon rank sum test, U1 equal to what? U1. U1 you should get 15. U2 you should get
34.
U2 should get 34. Yeah. So the Mann-Whitney test statistic, yeah. So the Mann-Whitney test statistic will be, so 134. So Mann-Whitney test statistic, the minimum of these two, so the U statistic is equal to minimum
15.
So minimum of this, so this is equal to 15. Okay, so the lower critical value should be 12, right? 12, and the upper
Yeah.
critical value is 37. Yeah. So the lower is 12, the upper critical value is 37. Do we reject or not to reject H naught?
Do not reject.
Fail to reject. Okay. All right. So the next one, question number 2. Look at question number 2. Okay. Question number 2. Use the Wilcoxon rank sum test. When we test both with alpha to test whether the claim is valid. Alright, so claim that the tar content brand is lower than that of brand B. Here. Now, for this example, if you look at this example, I mean for this question, for this question, I want you to test, I mean these two, use Wilcoxon rank sum test, then we need test both with to test. Okay. So meaning that here, well, actually here you do not have to make use of number 1 Wilcoxon rank sum test or Mann-Whitney test both. So you just use either one. Mann-Whitney meaning that this is directly use the comparison, comparison of x less to the left of x, number of y to the left of x, number of x to the left of y. So just make use of one. No need to do both. But here, okay, for this, since I know I want to conclude whether the tar content of brand A is lower than that of brand B, so I have to specifically write as brand B is lower. So meaning that median of B lower. Median H naught H1. So median B lower. So MB minus, greater than, lower than MA. Okay. H naught MA MB equal to ME. So for 2A, what do you get?
U1 19, U2 1.
Yeah, so you will get U1 equal to 20. U2 equal to U1 equal to 9.
19.
U2 equal to 1. Yeah. So the U statistic will be 1. U statistic should be 1. Okay. So the lower critical value, what is the lower critical value?
3.
3, right? Yeah. So reject H naught if 1 less than 3. Is it less than?
Yes.
Yes. So reject H naught. So based on Mann-Whitney statistic, find a point estimate of theta. What is the point estimate for theta?
There is no formula given in the notes.
Point estimate.
Tak ada formula apa.
Tak ada bagi tak sempat buat hari tu.
Tak, ada interval sahaja.
Oh, point estimate the same.
Guna median. Guna median
Dah. Just like what you have done before, the point estimate of theta. What is theta? Theta is the median of the difference. So here, so how to do that? So we need to, you need to, ini kan, So here you have 6, 6, 7, 8, 10. Ini for B, for here 9, 11, 12, 13, 14. I think they are different. So here minus 3, minus 2, minus 1, minus 1, kan? Sorry, this one. Okay, so theta hat will be what? Should be negative 4. Yeah, so after you take their differences, all these differences, well, of course, the last one here, minus 8, minus 8, minus 7, minus 6, minus 4. Yeah. Arrange this, all the differences in increasing order, and then get the point estimate of theta. Yeah, that is the point estimate, meaning that the median here. Yeah. So you will get negative 4. And for the lower interval, what will you get for the lower interval? Negative 6, kan? Yeah. And the upper interval, negative 2.
Negative 2.
Yeah, okay.
Prof,
Okay.
I want to ask,
Hmm.
usually is column minus row or row minus column?
What do you mean? Column minus row, this. Yeah? Okay, now here, let me see here. So, just a moment before I want to answer this. Okay, now look at this. Claim that the brand B is lower. B is here, right? B is here. If this is lower, because this specifically mentioned here, the tar content of brand B is lower than that of brand A. So here meaning that here this B, where is B? B is lower, right? B is here, right? This is B, isn't it? Here B. This is A, right? So if I specifically mention B is lower, so this minus that. This minus that. If I do not mention, because whether I just want to look at the confidence interval of the difference between these two. It's up to you. It doesn't matter whether you B minus A or A minus B. But here I specifically mentioned that B is lower than A. So B minus A. Is that clear? Who asked me that question?
Amy.
Amy. Okay. If specifically mentioned which is lower than the other one, you subtract the lower one. Otherwise, if I just want to find the confidence interval of the difference between these two, so it doesn't matter. This minus that or this minus this doesn't matter. Is that clear?
So that means B is lower, right? So should be 9 minus 6 because
Yeah.
A is higher.
Oh, 9 minus. Oh, yes, right. Yeah. A is B is lower than okay. Oh, here. Okay. We define okay. Oh, sorry. Here, yeah. This claim is for the testing hypothesis. Sorry for that. Yeah. But for number 2, I just mentioned 95% confidence interval of theta. Yeah, of theta meaning that the difference between the two sample. The difference between two population median. Yeah. So here, if I say 90% confidence interval of the difference between specifically mentioned B. Just now where here. This is what? This is B, right? B minus A. If I specifically mention confidence interval of the difference between brand B minus brand A. So I have to write this way. B here, right? B minus A. Yeah. Otherwise, if I just mention find the 95% confidence interval of the difference between the two population, doesn't matter. Okay? Is that clear? Yeah. For this already mentioned here is this brand B is lower than that of brand A is for testing the hypothesis. Yeah, for the testing hypothesis, we have to look at this statement. Yeah, whether mentioned or not, which is lower, which is larger, or whatever, whichever. If doesn't mention here, meaning that I want to test for the differences between the two. So H1 should be MA not equal to MB if I do not mention which is lower or higher. And for the confidence interval, if I do not mention, if I don't mention, like here, 90% confidence interval of theta. Theta can be the theta, meaning that this theta is the difference between MA minus MB or MB minus MA. Yeah, that doesn't mention. If I mention, it doesn't mention, doesn't matter. This minus that or this minus that is okay. But if I mention 90% confidence interval of the difference between B, I specifically mention confidence interval of the difference between B minus A. So you should write B minus A. B minus A. Does that answer your question?
Yes.
Okay, thank you. All right, now move on to the next one. Yeah. So here, look at this. Based on find the Hodges-Lehmann estimate. Well, this is actually the point estimate for this Hodges-Lehmann estimate of theta. Yeah. For the Mann-Whitney, we call Hodges-Lehmann estimate of theta. So for 3A, yeah. What is this? Yang ini dah what? Ini ya, 3A. What do you get for 3? Median?
13.045.
0.5. You get 30.045. And the confidence interval?
Lower is 15.07.
15.07, right? 15.07. And the
Upper 45.82.
upper 45.82. And you see here, I already mentioned mx minus my. Yeah, mx minus my. Yeah. All right. So here, number 4. So these were all very straightforward. Number 4, find confidence interval variance in the effectiveness of the two diets. So again here, for overnight, given to 5 other overnight with the following observed weight losses. So what do you get here?
Upper -2. Lower.
Lower negative
2.
confidence interval for median difference in the effectiveness of the two diet. Again, for this example, for this question, yeah, it's okay. It doesn't matter whether you A minus B or B minus A. Yeah, but you have to mention like here. If your answer will be different. Your answer will be different if you B minus A or A minus B. But whatever it is, you have to mention that you 90% confidence interval for the median difference in effectiveness of diet A. You have to write diet A minus B. If you write like this, because here effectiveness doesn't of the two diet can be A minus B or B minus A, but you have to mention in your here effectiveness of diet A minus diet B, or if you choose B minus A, B minus A. Okay. All right. I think that's all for today. Any question? I think it's already long, more than 1.5 hours. Because Monday we don't have class. Any question or not? So if there's no question, the test will be covered up to this Mann-Whitney test statistic. Yeah, it will be on Thursday at 4 o'clock. Yeah. And what I will do is that I will set the question. I will upload in the Putra Blast with restricted access where you can look at the question only at 4 o'clock, and then you have to submit by, well, let's say how many. Usually I give you more out time. Yeah. Let's say I give you up to 4:15. Yeah. And with 5 minutes interval. Yeah. So say by 4:20, but I might change the time, yeah, because sometimes when I think that you cannot do, I feel pity for you, then I will, whatever it is, yeah, uh, I will set the time, yeah. By the time when I think if I set the time to submit by let's say 4:20, you have to submit that quickly, yeah, because I give tolerance only 5 minutes, yeah. If I get, if I receive the submission, yeah, after 4:20, let's say, then yeah, it will appear that you have uh, uh, you have more than the time given, yeah, late submission. So what I want you to do after you answer the question, you you scan, yeah, and then send to the Putra Blast. Okay, send to the Putra Blast. Okay, any question or not?
Prof, I have a question.
Yeah.
For number 2,
Which number 2?
tutorial 4.
Okay. Uh-huh.
For number 2, if I do MA greater than MB, is it okay?
I cannot hear you. Can you speak louder?
For number 2, because brand B is lower than brand A,
Uh-huh.
so if I do MA greater than MB for the alternative hypothesis, is it okay?
Okay, no problem.
But it will become the right tier test, is it?
Yeah?
So it will become the right tier test.
Yeah,
Right
for
tier.
the right tail. Yeah.
And the rejection region, if after I try, the conclusion is different.
Oh, yeah, right. Yeah. So actually this may be the test, so it is recommended you make it lower.
Okay, lower.
Okay. Another thing before I forget. You should also know how to look at to get the p-value, to get the p-value. Let's say look at this man-Whitney test. Let's say your sample is 4. Let's say your sample size, let's say 5 and 6. Let's say sample size 5 and 6. And let's say your man-Whitney test, you get, let's say let's say 5. Let's say for X you get for X the sample is 5, and for the other one for Y, let's say 7, 5 and 7, 5 and 7. Let's say your U statistic, your U statistic that you get is, let's say you get 8.5. Let's say you get 8.5. Yeah, U statistic 8.5. So what is the p-value? The p-value, you have to look at my notes also, how to get the p-value. Forget to mention about the p-value. If in the question I ask you to make your conclusion based on the p-value, you have to show me the p-value. You do not have to show me the critical value. Show me how to get the p-value. Yeah. Okay, so let's say in the question, the sample for X is 5, and the sample for another and the sample for another sample for Y is 7. let's say when I calculate the U statistic, I get, let's say, 8.5. So what is the p-value? Dengar tak? Ha. Ha. Yes. Good. Yeah. So that then you have to look here. Mana tadi dah hilang pula ni. Here. Tengok sini. Okay. So the p-value should be between 0.05 to 0.1. Yeah. And let's say my U statistic is 12. Let's say my U statistic is 12. What is the p-value?
More than
Yeah.
0.1.
Yeah, can I hear you? Please louder.
More than 0.1.
Okay. So the p-value should be greater than 0.1. So you are also responsible to know how to get the p-value. Yeah, you are responsible to know how to make conclusion based on the p-value. Yeah. So for this, you have to look at my notes. Yeah. Yeah, and try to know how to calculate the p-value. Yeah, not only for the Man-Whitney, also for the Wilcoxon-San rank test. Okay. Any question? Oh, ready lah pas 9, 9:30, 10:30. Dah lebih 2 jam setengah ni ya. Dah ya? Ada question lagi tak? If no question, then mana tadi?